Well, finally, our last one, parts G to H. In this one, we're going to be having a look at how to write your A and B level answers on your exam. So we'll start with our B level revision. Something that you could appear in our B level exam is the law of conservation of mass, which basically states that matter can't be created or destroyed. There's a set amount of matter in the universe. In other words, when we're looking at our chemical formulas, if we have a look at the mass of the products, is going to be the mass of the reactants. So in the formula below, calcium carbonate makes calcium oxide and carbon dioxide. We're going to need to have 50 grams of calcium carbonate to add up to the 28 plus 22 in our products. 50-50 on both sides. Nothing's being created, nothing being destroyed. Same with our magnesium plus oxygen makes magnesium oxide. We're going to be looking at 32 grams of oxygen to get us up to our 80 balanced on each side. We did an experiment in class which had a look at bicarb soda and vinegar. Now when we did this experiment the first time, we added the bicarb and the vinegar together, we weighed them before, we weighed them after, and some of it disappeared. Well, we know that because of the law of conservation of mass, it can't have just disappeared. And so we put a balloon over the top, it caught the gas, it weighed the same before and after, which meant that in our first experiment, some of the gas had been let off, which means that our weight wasn't the same. But when we caught it all, the weight at the beginning and the weight at the end, or the mass at the beginning and the mass at the end, were the same. In our second experiment in class, we burnt some magnesium. And with magnesium, the weight actually increased. Now, we can't create matter. Law of conservation of mass says that we can't. But we can take some from the air around it. So magnesium burns to produce magnesium oxide when it combines with oxygen in the air. Now, when we added that oxygen to the metal, it increased in mass because we didn't weigh the air around it before we started the experiment. So there are two examples of how the law of conservation of mass might not seem consistent, but actually is when we have a bit more in-depth look. Another question that you could get in your B levels is dealing with an acid or a base spill. So basically, they'll present a scenario, and the scenario will require you to do one of the following 6 things. So you could do nothing, add a strong base, add a weak base, something to dilute it like water, a weak acid or a strong acid. That could be your 6 things that you could choose from in your answer. So when we're having a look at question 1, the spill is in contact with human skin. The best course of action is to add water to dilute the spill. Adding water when it's coming into contact with human skin is going to cause it to become diluted. Even though it's not going to neutralize it and it might still be acidic, it won't be causing as much damage. If you were to put, for example, if we had an acid spill on human skin, you would put a strong base on there, yeah, you might neutralize it, but you could also damage the skin as well. When we have a look at question type 2, the spill is not in contact with human skin. The best type of action depends on where the spill occurs. If it's contained, so if, for example, in a science lab you wanted to neutralize some, like a strong acid, you could use a strong base to neutralize it. But if it's not in a science lab, so it's somewhere else, say for example on a roadside, then if we had a strong acid spill, if you put a strong base in there, we could spread that mixture even further and it might neutralize everything. So in that instance, we might only use a weak acid or base to neutralize. In terms of writing it, so when you're writing your answer, the best answer to do this, to get your B level, is to explain the best option for dealing with it and why it's the best, and then explain why the other options weren't as good. So in example 1, a very strong acid has been spilt onto a road. Determine the best way to deal with this problem. So if we're having a look at our example response, we should see those 2 sections there. So the best way to deal with this problem would be to use a weak base to neutralize the solution. All right, tick. We've done the first part. We've done the best option part that we were talking about before. If you were to give me that though in your exam, you're looking at a low B, if that, because you've only told me which one is the best option. You need to explain why the other options aren't as good. So this is better than using a strong base, as this may cause further problems in an open environment. Alright, that's one of our options. Adding an acid is not practical, as this would only make the solution more acidic. Another one. That covers both our strong and our weak acids. And adding water to dilute the acid would result in the spill spreading. So we had a look at all of our options. We discussed why the first one was the best option. Alright, having a look at our A-level revision. So the A-level revision on the exam is going to focus on some of those word equations that we've had a look at for neutralization, looking at combustion, and also acids with carbonates and acids with metals. So you are going to need to know these following formulas off by heart. An acid plus a metal makes salt plus hydrogen. How can you possibly determine what salt's being produced though? So in the question it might say we've got hydrochloric acid and magnesium. That's obvious, that's an acid and that's a metal. How do we figure out what salt happens? Well, there's a helpful little table that'll help you. So on your worksheet, you'll see this exact same tables from your worksheet. You need to determine what type of salt is being produced. So have a look at kind of the clues there. If we've got hydrochloric acid and iron in our first box, and it's being mixed together, we're taking the iron from the metal and the chloride from the chloric to get our salt. If I'm having a look at the nitric acid, now the nitric acid, I'm going to use that iron again, so they'll see the iron appear in here. And you thought my highlighting skills are bad. And we should see our nitrate following it. So it'll be iron nitrate. And when it's sulfuric acid, it becomes sulfate. So when we're trying to figure out what salt it is, we just use the metal that it was mixed with initially, and then we just determine what, because of what type of acid it was, whether it's going to be a chloride, whether it's going to be a nitrate, or whether it's going to be a sulfate. Alright, when we're having a look at acids and carbonates, acid plus a carbonate will make a salt, a water, and carbon dioxide. Same thing when we're looking at our carbonates. So the first part of our carbonate, calcium, in this case, calcium carbonate, I'm going to have a look at nitric acid this time. Oh look, there it is again, calcium. And we've seen this word here before, nitrate. So remember that when we're dealing with our salt being produced, nitric becomes nitrate. When you're doing your very first box, this one here, we're going to have the word calcium in here. And when we're talking about hydrochloric, what salt does it produce? It's going to be a chloride, calcium chloride. So you need to finish that table as well on your worksheet. When we have a look at our next one, acid plus an alkali for salt and water. So this is our neutralization reaction. So sometimes it might be an acid plus an alkali or acid plus a base, depending on the wording. For this one here, we're going to have a look at sodium hydroxide and potassium hydroxide. So our acids are on this side. Name of acid. And these two, sodium hydroxide and potassium chloride, are our alkalis. This time, it's the name of our alkali that gets carried on. So everything in this column here is going to be sodium because we're all looking at mixing an acid with sodium hydroxide. This one here, they're all going to start with potassium. Potassium hydroxide. But where do we get these end bits from? We've seen these words before. They come, of course, from our acids. So sodium chloride, the sodium comes from the alkali, the chloride comes from the chloric at the end of our acid. Alright, on your page, the last thing that you need to do is using these word equations to determine what is being produced. So we've got our reactants here, hydrochloric acid and zinc. What are the products going to be? So think back. When you have zinc as our metal and hydrochloric, what's our salt? I've given you along the side here a hint for each one. So all you need to do is go back and have a look at the formula and it'll tell you the rest. So remember that with a metal, we're going to be adding hydrogen on the end. Salt has a hydrogen. When we're talking about carbonates, we're going to be adding carbonate on the end. So you need to know those formulas off by heart for your exam. Well, that's it. It's our last revision. So good luck on your exam next lesson.